We're ready.
You may begin.
Good afternoon. I'm Alec. This is Craig, Brian, Zach, and the rest of our team right next to me. We're representing Western Michigan University's concrete canoe team and our entry, the Italian Stallion. We're going to talk about our 4 biggest innovations from this year, starting with the introduction of a new major into our team, using advanced hull design, reimagining the rib application process, and the enhanced craftsmanship on the canoe. With more information on the hull design, here's Zach.
So this year for the Italian Stallion, we decided to introduce the engineering design major to the program. By doing so, we were able to create and model a more advanced hull design. The hull design this year was created using a design board, during which the team created 3 unique right side views. We then split up into 3 different groups and then created 3 unique canoe designs. We then, after some careful consideration, selected this year's design. This year's design is based off of the V1 Provo. We decided to enlarge the bubble and move it from center to 1/3 to the rear, which will aid in our straight line tracking, stability in the water, and our ability to turn the boat. We also added skegs to the rear of the boat, which will aid in propulsion as well as our straight line tracking in the rear of the boat. So this year's main goal was straight line tracking. After a water test, we did in fact accomplish our goal, and we did that through the use of our 1/3 to the rear design and the introduction to our skegs. Now over to Craig for structural analysis.
Thanks, Zach. This year when we began structural analysis, we treated the canoe as a channel-shaped beam continuously supported by uniformly distributed hydrostatic pressure. From there, we analyzed each load case the canoe would endure, and as you can see from our shear moment diagrams, the governing load case was our co-ed race. After that, we began our rib design. We first placed 2 longitudinal ribs along the tops of the gunnels and 1 along the bottom keel for moment resistance. We then placed 5 transverse ribs at our maximum shear points to resist those shearing forces created. Finally, we crossed 2 torsional ribs along the center of our canoe to resist the torsional forces created from paddlers working on opposite sides of the canoe. Here, more mixed design is Brian.
Thank you, Craig. With the utilization of an advanced hull design, the mixed design team's main goal was to increase workability without compromising compressive strength. The mixed team determined 2 desired properties for each mix: cohesiveness and low viscosity. The use of metakaolin as this year's SCM contributed to better workability, finishability, as well as compressive strength. For the skin mix, an increase in the amount of pore air and a decrease in the amount of ADA contributed to more round aggregate particles, which ensured better workability. As for the rib mix, various sizes of 2NS seine were utilized to maintain the desired workability required for the new rib application process. Appropriate water to latex ratios were determined through testing to obtain both these properties. In addition, the skin and rib mixes registered slumps of only 1 and 1.5 inches respectively, maximizing strength development. As for construction, there was multiple constructability issues. The team decided to utilize a female mold for the first time in over 5 years to more accurately represent the hull design. The main issue faced was trial inexperience. With 5 large-scale casting day simulations, as well as weekly trialing practices, the young members were able to gain experience and confidence in trialing for casting day. In addition, another issue faced was a new rib application process challenge, which Craig will elaborate on.
Thank you, Brian. Once we decided we're using a female mold, we had to think of a new way to apply our ribs. After a few considerations, we decided squeeze bagging would be the most effective way. After we cast our canoe, we scored the rib layout using a laser to be precise, and for the scores themselves to help with the mechanical bond between the ribs and the hull. 24 hours later, a smaller team came back to apply our ribs. We first started by moisturizing the scores to prevent absorption from the rib mix. We then added a cementous slurry to ensure a chemical bond between the 2 mixes. We laid our first bead of concrete, placed our reinforcement, laid our second bead of concrete, and with the handcrafted tools we made, we finished our rib layout. Here's Adam with our conclusion.
Thanks, guys. As you just heard, we were successful in implementing a new major into our team, enhancing the craftsmanship on the canoe, using an advanced hull design. We'd like to thank Michigan State for hosting and the judges for their time. We're now open for questions.
You mentioned a couple times you introduced a new design, the engineering design major in your team. How in fact did you go about doing it? Did you just hop in one of their classes and say, hey, you guys can join our team?
Yeah, I'll actually speak on that. So I was actually the head of the designers this year, and I am an engineering design major myself. So it made it really easy because I'm sitting in class with these kids that would be vital to our team. And so I started talking to these guys about it. Hey, come out, check out the boat, come hang out with us. And we got a fairly large team out of just word of mouth and spreading it around. And we hope to increase our productivity from these designers and get more designers by going to classes, by showing up to the entry-level design classes and speaking to them about actually joining this team. Because we want to make sure that we have a strong design team from here on out.
Do you have any issues in terms of slippage from your schedule? And if so, how did you get that on track?
I'd say there wasn't any major slips with the schedule. We did move casting date back a week early, which contributed to adjusting the schedule a little bit. But for the most part, we were on schedule, and we integrated sufficient flow to account for any variance and issues. Hard work, I would say persistence. You have to, communication is key. I think that's one thing we learned this year, implementing a new major into the team. That's something that we definitely need to work on. Communication is imperative, and weekly meetings to make sure we're on schedule.
You get your rib mix is almost 5 times the compressive strength of your steel mix, and then poured it, replaced it 24 hours after. Can you explain the design philosophy that you know?
I would say the reasoning for the increased compressive strength, substantial compressive strength, was due to the strategic placement of the ribs at our maximum stress points. And in order to achieve that, we needed to have a stronger mix, so we sacrificed the average unit weight to achieve that.
You talked about the loading scenario that you did, but I didn't see anything in the presentation or, and you just briefly mentioned it in your paper about transportation loading scenarios. Did you do that? And so are those, what kind of results do you think?
We didn't actually analyze those transportation scenarios because it wasn't an issue last year. The issue we faced with transportation this year from the Craig and our canoe was the paracord themselves that our canoe was sitting on was dry from last year and they broke, and the canoe hit the bottom of our casket and cracked during transportation.
You've got 2 skegs incorporated into the canoe. Could you briefly point at
Absolutely.
where those are at?
Yeah, absolutely. I can actually hand this around to you if that would make it easier. The skegs are located right there on the rear, and I can actually pull up the slide. So we placed the skegs here on that lower third, that rear third section, and the concept being is that one, it's going to allow us to have propulsion, and it'll also add buoyancy to the back of the boat because the material that we use, that we put inside those skegs, is less buoyant than is more buoyant than water. So our skegs were strategically placed to the rear to aid in propulsion, turning, and also keep the back of the boat from veering off course.
You mentioned you did water tests. What kind of water test did you do?
That's an excellent question. So our water test was pretty simple. We ended up with our 3D model, we put it in the water, and the main goal, like I said, was straight line tracking. So instead of doing a dynamic test, because essentially we just didn't have time, it was too late, essentially, we had already designed the boat. We wanted to make sure that what we were doing was the right thing. So we created a rubber band, almost slingshot, and what we did is we charged it back in a tub of water and released it, and made sure that it did in fact stay on a straight line. And that was essentially our main goal, was to make sure that it stayed on a straight path. So that was our water test.
Can you explain a little bit how you tested and determined what type of reinforcement you used this year?
So we did some research on different reinforcements. We've used spider lathe for many years. However, since we are decreasing the concrete density so much this year in comparison to last year, we figured because of the low tensile strength of concrete, we figured we would counteract that with a stronger tensile reinforcement in carbon fiber. That was our best option.
Can you elaborate on your safety protocols or programming that you use during the process?
So it's basically a 3-step philosophy. Material knowledge, you have to know what's in the material and what's going to harm you in that material. material awareness, when is that, when are those harmful chemicals exposed? And finally, personal protection, you wear safety glasses, you have to wear respirator.
So did you guys do like, you know, lots of talks before your practices or gas day, stuff like that?
Yeah, before each trauma practice, we would, especially the new members, because they, you know, don't have a great idea what's going on, we would tell them, you know, you gotta wear gloves, all these safety protectors and everything. Yes.
You define what you mean by large scale casting days in your trials?
Yes, so basically we, with the new mold, we hadn't had utilized a female mold in over 5 years, so it was extremely new process for everybody. So what we did was we took a sonotube form, what they use for pole foundations, cut it in half, that simulated the curvature of the female fall. And basically we could put staple screed rails in just like for a QC, for a uniform hull thickness. And basically we had our advisors there teaching us how to trowel, so all the young members would get the technique down and simulate what casting they would have done with the, our assembly line and everything like that.
Do you have any resource constraints? And if so, how did you deal with those type of constraints to overcome?
Resource constraints, we had a lot of donated material this year, which was imperative for us. We spent quite a bit more money than we did last year. So I would say donations go up. Yeah.
You explain, you used a medicated in your mix, what is that? How is it
Well, I can tell you what we used it. Sure. We used it because it's a fine material, and that contributed to the fineness, or that contributed to workability, finishability, and the cream color helped with not burying our pigment as opposed to other SCMs. So that's why we chose it, as well as increased strength benefit.
Okay, good question, Michigan, thank you very much.